Good evening, class. Welcome to today's online PPS class. In our yesterday's session, we have discussed about the memory allocation concept. We said memory allocation, it can be of two types. Static memory allocation will be done at the time of compilation of the program. Dynamic memory allocation will be done at the time of execution of your program. Okay. So whatever approach we followed till now for allocating the memory, we said it is static memory allocation and will be done from the stack. Okay. If we see the conceptual view of our program, the complete memory which is allocated to the program is divided into different sections, the program section and the data section. Inside the program section, we said the complete program code will be saved, the instructions will be saved, and in the data section, all the data, whatever we create, variables, arrays, pointers, structures, unions, all they will be stored inside your data part. Okay. So this data we said is of two types. One is stack data, other one is the heap data. Stack data will be allocated to all the local variables, whatever we declare in our program, and heap data will remain unused. So to use this heap data, okay, heap memory, what we have to use this heap memory, we need to go for memory allocation functions. And we said we have four different types of memory allocation functions. In that, the first one is malloc. We also call it as block memory allocation, that we have already discussed. Uh, with example program demonstration, I have given the explanation related to this block memory allocation. Then we have the calloc that we will discuss in today's session, and realloc that also we will discuss in today's session, and free function. Free we already discussed, just to release the memory, whatever heap memory we are utilizing in our program. Once the purpose is done, once the purpose is over of utilizing that heap, we need to release. Once the job is done, we need to release that heap memory. Okay. So to release that heap memory, we said we use the free function. And all the dynamic memory allocation functions, they are part of your stdlib.h, standard library.h header file. So whenever we use this dynamic memory allocation functions in our program, we must need to include standard library header file, stdlib.h header file into our program. Okay. So, and after explaining about calloc and realloc, two functions we have already discussed now. Okay, let me just take you to that section. See, what is left is only the memory allocation functions. In that memory allocation, two types of functions are left from your fourth unit. And in today's session only, hopefully, I will start your fifth unit as well. Okay, I will give some of the basics. I mean, at least syllabus we will discuss in today's session. Okay, after the discussion of two of the remaining dynamic memory allocation functions, we will go for fifth unit as well, and we will discuss a few of the basic things in fifth unit. Okay, so memory allocation functions. Yeah, here we have the memory allocation. Yeah, here you can see our conceptual view of memory. Whatever memory is allocated to our program, this is the conceptual view. We said we have the program heap and program uh, stack, yeah, system stack. On it, all the local variable will be stored, and on it, the dynamically allocated memory will be stored. Okay. Among all these functions, here we have four different types of functions as we discussed yesterday. Your malloc, your calloc, realloc, and the free function. So among all four, we already discussed about malloc, the block memory allocation, and the second one, the free function. Also we discussed to free the memory, to release the memory, we use free function. These two we have already discussed now. And in today's session, we'll be discussing about calloc as well as realloc. Calloc I will explain, and then calloc stands for contiguous memory allocation, and then realloc stands for reallocation of the memory. Okay, so these two we will discuss, and then we will go to fifth unit now. So block memory allocation program demonstration also I have done in yesterday's session only. So today we will discuss about contiguous memory allocation function. Okay, calloc, contiguous memory allocation function, calloc function. It is also a dynamic memory allocation function from your standard lib.h, standard library.h header file. Okay, so it is different from a malloc, where it sets the memory locations to null characters. So empty it will make. So we said now malloc will allocate the memory locations from the heap, and those memory locations will remain uninitialized. Okay, malloc లో ఏదైతే మెమరీ అలోకేట్ అవుతుందో అమ్మా, ఏదైతే మెమరీ బ్లాక్స్ అలోకేట్ అవుతాయో, they will remain uninitialized, so they will hold garbage value. Okay, we have another slide ma where we discuss the differences between calloc and malloc, because both purpose is similar. Okay, they are having some similar purpose, so we need to discuss the differences between calloc and malloc, because both calloc and malloc are used to allocate the memory from the heap only. Okay, so here one of the difference between calloc and malloc is calloc will initialize the memory locations to 0 to null character likewise, but your malloc, it will not touch your memory locations, and whatever memory locations we get from the heap now, it will return same. Okay, so they will remain uninitialized, or they will hold garbage values, we can say. ఓకే, మెలాక్ లో ఏవైతే మెమరీ లొకేషన్స్ అలొకేట్ అవుతాయో అందుట్లో ఏముంటుందమ్మా, అందుట్లో గార్బేజ్ వాల్యూ ఉంటుంది, సమ్ మీనింగ్లెస్ వాల్యూ ఉంటుంది. బట్ వేరాస్ కెలాక్ లో అలొకేట్ అయిన మెమరీ లొకేషన్స్, దే విల్ బి ఇనిషియలైజ్ టు నల్ క్యారెక్టర్స్ ఆర్ జీరోస్. ఓకే, just keep this thing in your mind. Okay, and this is the syntax to use the calloc function, calloc memory allocation function. It will take two parameters ma. This is another difference between calloc and malloc. Malloc will take only one parameter, but here calloc will take two parameters. One is the block size, and other one is the number of blocks. Two parameters it will take, block size and number of blocks. So suppose if you give 5 as count here, and 2 as element size here. So what will happen? 5 blocks each of 2 byte size will be returned. 5 blocks each of 2 byte size will be returned. Likewise, this calloc function will work. We have two parameters to calloc function. One is the number of blocks, and the other one is the size of each block. Element count and element size is nothing but, element count is nothing but how many elements you want, how many such elements you want, and element size is nothing but what should be the size of each element. That is what here. And it is also, your calloc function is also returning a generic pointer. As you can see here, the return value or return type of your calloc is the generic pointer. It will return an address of the first memory location of the allocated contiguous blocks. Okay, hope you understood. What it will do, it will allocate all the blocks contiguously, and it will return the first memory location's address in the form of a generic pointer. Okay, so wherever you use this calloc, in order to store a specific type of value into those heap memory locations, you need to typecast with specific pointer. ఓకే, ఇంటీజర్ వాల్యూస్ స్టోర్ చేయాలి అంటే ఆ మెమరీ లొకేషన్స్ ని ఎలా టైప్ క్యాస్ట్ చేయాలి, ఇంటీజర్ పాయింటర్ తోటి టైప్ క్యాస్ట్ చేయాలి. క్యారెక్టర్ మెమరీ లొకేషన్స్ క్యారెక్టర్ వాల్యూస్ స్టోర్ చేస్తున్నారు అంటే క్యారెక్టర్ టైప్ ఆఫ్ పాయింటర్ తోటి టైప్ క్యాస్ట్ చేయాలి. ఎస్టర్డే సెషన్ వి హావ్ సీన్, ఎస్టర్డే సెషన్ లో మనకు రిటర్న్ అయింది వాయిడ్ పాయింటర్ ఫ్రమ్ ది మెలాక్ ఫంక్షన్, బట్ వి టైప్ క్యాస్టెడ్ ఇట్ టు ఇంటీజర్ పాయింటర్. Okay, hope you understood. So on successful allocation, once it has allocated the memory successfully, what it will do, it will return a void pointer to the first byte of the allocated memory. Here you can see that one. On successful allocation, your calloc function, it in the sense your calloc function, it returns a void pointer to the first byte of the allocated memory. Whatever memory it is allocating, it will return the address, a void pointer to the first byte of the memory. Okay, and if the allocation is failed, if the memory allocation is unsuccessful, then what will happen? Yesterday also we discussed, if on unsuccessful allocation of the memory, it will return a null pointer to indicate no memory has been allocated. Okay, to indicate no memory has been allocated, it will return a null pointer. Okay, quickly we see a demonstration of this calloc function, dynamic memory allocation function, contiguous memory allocation function, calloc. This is the demonstration. So first what we are doing, we are reading the number of elements that you want from the heap. Okay, and each element, as you can see, previously it was n multiplied with size of int, but now it is n comma size of int. Okay, because that many number of blocks it will create, not a single block, that many number of blocks it will create, each wherein each block will be of size integer, 4 bytes, wherein each block will be of size integer. So calloc is the function name, number of elements or number of blocks whatever we need, here we are reading and that we are passing here. Okay, then each block will be of size of integer, we are saying, and whatever it will return, the calloc function, that will be a void pointer, isn't it? Void pointer, in the syntax we have seen, it will return a void pointer that which we are typecasting to integer pointer. Here ptr is an integer pointer. By typecasting, I'm storing the generic address to integer address, I'm converting generic address to integer address, and that integer address I'm storing into this integer pointer, ptr. Hope you understood. And then after storing the address, immediately I'm checking whether it is null or what. If it is null, that means no memory has been allocated. If the returned pointer is null, it means no memory has been allocated. Accordingly, I'm printing a message that memory not allocated. And I'm exiting from the program. If no memory has been allocated, there is no point of moving ahead and doing all these things. So what I'm doing, if no memory is allocated, here only I'm exiting from the program. Hope you understood. Okay. Then if pointer is not null, if pointer is not null, that means it is holding the address of first byte of the memory which is allocated, isn't it? It is holding the address of first byte of the memory which is allocated. In that case, what we have to do? In that case, what will happen? This condition becomes false and the control goes to the else part. So if it is going to the else part, I am printing a message that memory has been allocated successfully using malloc function. Memory allocated successfully using malloc function, and that many number of elements I am reading and simply storing into that array. So basically, whenever you want to, because all memory locations are contiguous, isn't it? All our memory locations, when we allocate using calloc from the heap, they will be contiguous. So we can use this calloc function to allocate the memory for an array, dynamic memory for an array. Okay, so that elements I'm reading and I'm storing into the memory, heap memory, and same thing I'm printing. After storing, same thing I'm accessing and I'm printing and I'm exiting. Okay, while exiting from the program, while coming out from the program, what I'm doing, I'm destroying the heap memory, whatever it got allocated to my program. Okay, whatever I have used in my program, using simply by freeing this ptr, what I'm doing, I'm deallocating that memory. Okay, I'm destroying that memory, I'm deleting my variables from that memory, I'm deleting my values from that memory. Hope you understood. Okay, so quickly we'll do the demonstration. The same program I will try to execute on, to show the output, I will try to execute on dev cpp. So here what I'll do, I'll open an empty file and I will include my uh, header file, and also I need to include the stdlib.h hash include stdlib.h, then my main function. Okay, then init create the pointer. We need integer pointer because we are going to store the integer values into the heap. And for running the loop, I'm using one counter, and for running the number for reading the number of elements, I'm using another variable n. Okay, now what I have to do, just allocate the just read the number of elements. Printf enter the number of elements that you want from heap. Elements you want from heap, from heap. Okay, that what I have to do, that I need to read into n variable. So percentile d comma ampersand n. Okay, next thing, after reading I need to allocate the memory, isn't it? So how it will allocate? Calloc of n comma size of int, size of int. Go to the end, go to, yeah, this particular thing will be in the form of generic pointer, so I need to typecast into integer pointer. Int star is nothing but integer pointer, integer address, and that I am storing into ptr. Hopefully it is clear. Now what I have to do, I need to check whether ptr is null or what. If ptr is null means no memory is allocated. If ptr is not null means memory is allocated, then we can store the elements into it. Okay, so how to check? If at all ptr equals to null. Okay, so then here what I have to do, because the memory will be allocated successfully, I need to print a message that so not successful, memory allocation failed, heap memory allocation failed, heap memory allocation failed. Okay, give a sad face here because memory allocation failed, and just exit. If no memory is allocated, in the sense, exit from here only. No point of moving ahead and doing other thing. Then if that particular condition is false, then go to else part and perform other things like read the elements. Printf enter percentile d elements to store into heap, to store into heap. Okay, and that percentile d will be n. Okay, put the semicolon at the end, and now use a for loop. I equals to, because 5 elements I need to, I mean whatever number of elements I will input, that many elements I need to read, so I need to use a loop. I less than n, I plus plus. Okay, then come down, read it. Okay, read it, scanf percentile d comma ampersand ptr of I, sorry, ptr of I. Okay, reading is over. Now printing. Printf, okay, elements in the heap are, okay, put semicolon, again use one more loop. I equals to 0, I must be less than n, I plus plus, and come down, use a printf statement to print the elements. Printf percentile d space comma what is that, ptr of I. That's it. Okay, now after coming out of this else, simply destroy the pointer. How to destroy the pointer? Free of ptr. So this will release the memory whatever we have allocated using this calloc. Okay, this is the program. Very simple program to understand, because yesterday also we have done a similar program, and here you print a message. Okay, because memory allocation successful now, inside the else part you print a message. Printf Heap memory allocation successful. Heap memory allocation successful. Okay, and give a happy face like this. Okay, so save it. Now we need to give the semicolon at the end. Now save it. Kellogg mem.c. Okay, uh, compilation successful. As you can see, execute. Yeah, here it is asking me to input the number of elements that I want. I'm saying 5 elements I want. So to avoid all this nuisance, I mean, in the same line, it is printing, right? So what I'll do is backslash n. In every printf statement, I will use backslash n, and just to have all these lines in separate lines, all these statements in separate lines. Here also put one backslash n, and here also you put one backslash n. Simply save it, compile it, run it. So it is asking me to input the number of elements that I want from heap. I'm entering 5. Heap memory allocation successful. Enter 5 elements to store into heap. Okay. So here I'm inputting 1, 2, 3, 4, 5. Okay. Hit enter. See, elements, they got stored in the heap, and elements in the heap are 1, 2, 3, 4, 5. Like that it is printing. Hope you understood. And whatever memory we are allocating here now, whatever memory we are using here, it is not similar to the one which we have used previously to store the elements. It is from the heap. When we are using Kellogg, Melloc, it is from the heap. Okay, a different category of memory in our program's memory. Uh, we call it as heap memory. And how to manipulate it? Using memory allocation function, or memory dynamic memory allocation functions, or memory manipulation functions. They are Kellogg, Melloc, realloc, and last one is free. So 3 we have already discussed. Kellogg is over, Melloc is over, Kellogg is over, and free is also over. Our next type of function, memory allocation function, is realloc. Okay, so before we go to that, we need to discuss the differences. As we said now, both will look similar. Your Kellogg function, Melloc function, both will look similar. So we need to discuss the differences between Kellogg and Melloc. And it is also an important question, maybe for 2 marks, or maybe they will put this question under long answer questions as a bit also. Or we can't say. So key differences between Melloc and Kellogg are dynamic. I mean, in both cases, dynamic mapping will be happen. Okay, and Melloc allocates a large block of memory of certain size, while Kellogg allocates small blocks of certain amount. Okay, so that is the difference. The Melloc and Kellogg functions differ in how the functions are used while allocating the memory at runtime. Okay, uh, the Kellogg function returns the starting address. It doesn't zero it. That means Melloc function will not initialize all the memory blocks. All memory blocks will remain uninitialized in the Melloc function allocation. All memory blocks will have garbage values. All memory blocks are uninitialized. But whereas when we use the Kellogg function, it returns a starting address by zeroing it. Okay, it will zero all the memory locations. It will initialize all the memory locations to 0 or null character. In case of a character, it will initialize all elements to null characters. Okay, same program here. If you want to use it for character, what you have to do? Simply typecast with character pointer, so that you can store the characters into the allocated memory. ఓకే, క్యారెక్టర్ స్టోర్ చేయాలంటే ఏం చేయాలి? అప్పుడు క్యారెక్టర్ పాయింటర్ డిక్లేర్ చేయాలి. ఇక్కడ ఈ క్యారెక్టర్ ని కూడా, ఇక్కడ ఈ రిటర్న్ అయ్యే మెమరీని కూడా మనం క్యారెక్టర్ పాయింటర్ తోటి అలోకేట్ చేయాలి. అండ్ రెస్ట్ ఆఫ్ ద ప్రోగ్రామ్ ఈస్ సేమ్, బట్ హియర్ వెన్ రీడింగ్, here we are reading integers, but you need to read characters to push into the pointer. And here also same thing. Let me just try this one, because in your syllabus they mentioned memory allocation function for different data types we need to discuss. Here you can see I'm going to the syllabus actually. Here uh, where it is, yeah, allocating and freeing memory. How we allocate, how we free the memory, that we need to discuss. And allocating memory for arrays of different data types. Arrays of different data types అంటే ఏ టైప్ అయినా మనం సింపుల్ గా అక్కడ చేయాల్సింది ఏముంది, కెలాక్ ఫంక్షన్ లో we just need to change the pointer here. Okay, I'll use it for characters now. So character ptr, so I and n. Here number of elements I'm reading, na number of items, number of such items I'm reading, so n only. And here it should be character pointer, and here it should be the size of character. Okay, size of character. And this thing same, checking whether ptr is holding null or what, checking, no difference. And in the else, if ptr is not null, that means memory got allocated successfully. And here that many elements of what type of character. So here I'm mentioning character to store into heap. Okay, how it will go we will see. Then I equals to 0, I must be less than n, I plus plus, percentile d, ampersand, not percentile d, percentile c you take, and ampersand ptr of I. Then printf elements in heap are, here also you print using c. We just see how it will work. Compile, as you can see it is successfully got compiled. Then execute. It is asking me to enter the number of elements that you want from the heap. I'm saying 5. Yeah, now it is asking me to input the 5 elements of character type to store into the heap. So first A I'm inputting, then B. Okay, so it is taking only 2 ma. Why means because it is considering the new line character also as a character. Because after entering each item, I'm pressing the enter key. So it is considering that enter key also as a character. So that's the reason it is reading 1, 2, 3, 4. Okay, let me just try with another way. Because in that time also what will happen? It will consider all spaces as characters. Let me just try this. Enter the number of elements you want to store, you want from heap. I'm saying 5 items, 5 elements. So elements 5, enter the element 5 elements to store in the heap. So if I give a space, b space, c space, d, in that case also it will consider, I guess, only a b c or a b only. See, it is considering a b only because the space which I am giving between these a and b, that will also be considered as a character. So that's the reason it is storing only 2 with 2 spaces and the starting character. Likewise it is considered. Okay, hopefully you understood. So next, float we will try. Float pointer. Here also what we have to float, and we need size of float. And here percentile f. Here also percentile f. Okay. Hopefully this is it. Yeah, we'll see how it will go. Execute. We said 5. It is no, not character. Now it should be float. Okay, let me just save it, compile it, run it. So now 5 I'm saying, it is asking me to input 3.14. Okay, 2.13. Third one 5.6264. Fourth one 2.56. Okay, and another one 6.54. See here, all elements it is printed with spaces. Whatever I have inputted over here, whatever I have given input here, 1, 2, 3, 4, 5 elements, it is storing into the heap and it is reading from the heap. Only in case of characters, the reading and writing process will go somewhat weird, because whatever character we use to give the space between two characters, between reading characters, those, even if you give blank space, that blank space will also be considered like a character only. That's the reason it will not go smooth. Input and output in case of character, it will not go smooth. Rest of all, even you take double, long double, integer, long integer, long integer, short, except character, all other types you will get as it is. Okay, whatever we are discussing now, as per the discussion, you will get. Only for characters, you will get some weird output. Okay, so hopefully you understood, ma. So I have explained how to do for other types as well, not just the integer, how to do for other types, because every time your calloc function is returning a void pointer that we are converting to a respective pointer, a respective type before storing that type of values into that heap memory. Okay, hope you understood. So now we'll discuss the, we were discussing about the differences between calloc and malloc. Two we have already discussed. This particular slide. Uh, yeah, we said all elements, all heap blocks or all heap elements will be initialized to 0 if you use calloc, but malloc it will not. Okay, and another difference, as you can see, the fourth difference between calloc and malloc is your calloc it will take only one argument, but whereas your malloc will take only one argument and your calloc will take two arguments. Calloc will take two arguments, two what we call parameters or arguments it will take. And then the malloc is more time efficient than calloc. Calloc will consume a lot of time for execution, but malloc, as it has to do the block memory allocation, it will consume less time. But whereas calloc, as it has to do contiguous memory allocation. In today's session only, I told you, whenever we go for contiguous memory allocation, it has to look for the uh, contiguous free blocks before allocating the memory to the pointer, or before allocating the memory from the heap. It has to look for contiguous free blocks, and that will take some time. Okay, but yeah, in terms of safety, if you see now, your malloc is less safe. Okay, less safe, but whereas calloc it is more safer. Okay, more safer than malloc. Okay, yeah, the yeah, this difference we already discussed. Malloc does not initialize the memory, but calloc does initialize the memory. Initialization in the sense it will initialize to a default zero or null character likewise. Hope it is clear, ma. These are some of the key differences between calloc and malloc. Block memory allocation, contiguous memory allocation. Hope it is clear. We'll go to the next one. That is a reallocation of memory, realloc. Reallocation of memory, realloc. The concept is very simple, ma, here. Why we use this reallocation in the sense, suppose you have allocated some memory to some pointer in your program, say PTR, through calloc or malloc, you have allocated some memory. Okay, through calloc or malloc, you have allocated some memory, some size of memory that you want to modify, that you want to increase, or that you want to decrease. You want to modify. Okay, suppose suppose here you have allocated 10 uh, blocks, 10 contiguous blocks using calloc. Using calloc, what you have done, you have allocated 10 contiguous blocks of memory to this pointer. We know that how this function syntax will go while allocating this 10 blocks to this PTR. We know that. But later on, what you have decided by in your program, what you have decided, you want this to be modified. Okay, now you want more. Okay, say suppose 20. Then what you have to do to adjust this memory locations, to adjust these memory locations from 10 to 20, to increase or to decrease. Whether you may be going for 10 to 20, or you may be going for 10 to 5, increasing or decreasing, we use a realloc. So suppose if PTR is equals to, say suppose if I want 5 here, then I need to go for reallocation. Okay, reallocation. Same thing after some point, if I want 20, again what I have to do, I want to go with reallocation, and this time, as I said, I want 20 blocks. Like this you have to. Okay, so initially whatever memory you have allocated from the heap, to modify the size of that memory, to increase the size or to decrease the size, to increase or to decrease, simply go with reallocation. Okay, and this reallocation, it is not at all advised to use in the programming because it is having a lot of limitations, and with precise knowledge, with advice, you have to use. Okay, the reallocation function is advised to be used more care, with much care. As a minor issue in the usage will lead to the program crash. The complete program will crash if you do something problem, if you don't know the syntax, or if you what we call, if you have done some even after knowing the syntax, even after knowing everything about real log, even if you do a small mistake, small problem in the code, then there is a possibility that your complete program may crash. So because of that, it is not advised to use. Okay, or we can say advised to use, but with much care. Okay, so given a pointer to a previously allocated block of memory, what we are saying, to a previously allocated block of memory, realloc changes the size of block by deleting. So if you are decreasing the size, what it has to do, it has to delete the extra extra allocated blocks, extra blocks that you don't want. If you are increasing the memory, then what it has to do, it has to extend the memory at the end of the block. Whatever block it has allocated, it simply extends the memory at the end of the block. So when we do practical demonstration, program demonstration, there you will understand about it. So for now, you simply remember whatever pointer we have allocated previously using calloc or malloc, to modify the size, we use the realloc. Okay, and here also same thing, this realloc function, if modification extending is not possible because of any issues. Okay, because of any issues, if extension is not going possible, then realloc, what it will do, it will create a completely new block. Okay, completely new block, and copies the old content from the previous block. Old content copy చేసి కొత్త బ్లాక్ లో ప్లేస్ చేస్తుంది. Okay, so this is what it will do. And the syntax you can see here, realloc syntax. The function name is realloc, and it will take the old pointer and the new size. Old pointer and new size, and the return type, as you can see, void star. For some reason, if memory allocation not done, it will return null. And if memory allocation is done, it will return the pointer to the first byte of the allocated memory. Concept is same, కెలాక్ మెలాక్ ఎలాగైతే ఉంటుందో రియల్ కూడా అలానే ఉంటుంది. But here the syntax is different. While the calloc malloc will take the number of blocks, here the realloc will take the pointer, old pointer, and it will modify the size to the newly given size, and it will return the pointer. Hopefully you understood. So quickly we go and we demonstrate this realloc with the help of a program example. Here we have the program example. As it is a big program, it is spanning between two slides. Here we have only the half program, and remaining half we have here. As you can see, it is total 54 lines long. Here we have half of the program, and remaining half here we have with the output. Okay, so initially, as you can see, we are creating, and we are dealing with integers only here also. As you can see here, what I have done, I have created a pointer ptr of type integer, and here n comma I comma, as maybe I'm calculating sum somewhere, maybe in the next slide. Okay, nowhere I'm calculating my sum. I think this is a mistake actually. This sum equals to 0. How it came in this program, I don't know. It is basically a mistake. Just if I'm not calculating any sum, no need to use of no need to use this sum. Only two are enough, n and I. Okay, then I'm reading the number of blocks which I need, number of elements which I need from the heap, and that I'm storing into n, and using calloc I'm creating an array of that many elements. Each element is of size integer. Okay, and as calloc will return a generic pointer, I'm typecasting with integer pointer, and that I'm storing into ptr. Okay, so I'm checking whether ptr is null or what. If it is null, I'm giving a statement memory not allocated, And if it is not null, I'm giving a statement. Straight away, the control goes to the else part. If this is not null, the control goes to the else part, and I'm giving a statement that memory successfully allocated using Kellogg. Okay, then what I'm doing, I'm reading the five elements from the keyboard, and I'm storing those five elements into the heap. Okay, as you can see here, only the elements got pushed into the heap, and from the heap I'm printing the elements, and checking whether they successfully stored or not. Okay, then go to the next slide, and here you can see I'm modifying. I want to modify the previous old memory, so I'm reading the new size here, new size of heap, so that I'm storing into n, and using real lock, as you can see here, using real lock, I'm modifying uh, old pointer I'm giving, and the newly modified size I'm giving. Okay, n multiplied with size of n, newly modified size I'm giving. So that again I'm converting to a generic pointer, and I'm storing into PTR. And if this PTR is null, I'm printing memory not allocated. And if this PTR is not null, I'm printing memory allocated successfully here. And I'm reading new elements, pushing those elements onto the heap, and printing those elements from the heap. And finally, I'm releasing the memory once everything is done. Once the allocation and reallocation has been done, I'm simply releasing the pointer. Okay. So here you can see initially I started with five elements here. Okay, five elements. Then I read five elements, stored five elements. Then the new size, I modified the new size to three elements. So now I can have only three elements onto the heap after modification. So only three elements I am entering, and three elements I am printing. This is how it will go. So let me just demonstrate this. So I will modify the same program because the concept is simple. So what I have to do after printing the old items, I need to read the new size. So printf backslash n, here enter the new size for heap, for heap. Okay, put the semicolon, scanf, I'm reading into the same variable n, ampersand n. And now to allocate this new size to the old pointer, what I have to do? PTR equals to, yeah, float we have selected now, float we said now, so float only I will take, float star, comma, real lock of n. No, we need to give old pointer by modifying it to, I think, void star, because our pointer is in float, but whatever we pass here now, we need a generic pointer. So from float I am modifying to generic ఏముందమ్మా void star ante generic, put void star here. So from float to generic we are converting, because real lock will take generic pointer only, and n multiplied with size of float. Okay, like this, put the semicolon at the end, come down, and if we need to check if the pointer, that is PTR, if it is equals to null, means memory allocation failed, and exit. Printf, what we have to print, we need to print that uh, heap memory allocation failed, backslash n, heap memory allocation failed. Okay, uh, like this, and go to end, and here only we need to exit. If the memory allocation is failed, means here only we need to exit. And in the else part, what we have to, yeah, we need to read the elements. Printf backslash n, heap memory allocation modified successfully, heap memory modification updation successful, and we need to read the new items to be stored on printf to be stored onto the heap. Backslash n, enter percentile d elements of type float to store into heap. Okay, put the semicolon at the end. And now for all I equals to 0, I must be less than n I plus plus. Okay, then read them scanf percentile f comma ampersand ptr of I. Okay, then print just to check whether they got saved or not. Printf elements in the heap are. So again you take for loop I equals to 0, I must be less than n I plus plus, and printf percentile f comma ptr of I. That's it. Rest of the code remains same. Only this new allocation with new size we have done, and new values after updation of the heap memory, new values we read and we store into the new heap. Hope it is understandable. Compile it, successfully compiled, run it. What it is asking me to input, the size of heap 5 I am saying, and it is asking me to input 5 elements. Same thing, 3.21 first value, 5.26 second value, 4.23 third value, 6.51 fourth value, 7.89 fifth value. 5 values I have given. Hit enter. As you can see, it is printing all 5 values as I have given, and it is asking me for the new size. I'm saying only 3 elements now. So now again, heap memory updation successful. It is updated successfully, and it is asking me, I think n I have not passed, it seems here. See, percentile d elements, new elements, I have not passed the n. So now once again compile, execute. It is asking me 5 elements, 3.12, 4.15, 5.62, 5.78, and last one 9.21. Like this I have inputted. I have given 5 different float values. Yeah, it is printing. 3 I am saying, now it is printing. See, you can see heap memory updation successful. Enter 3 elements to store into the heap. Now 7.21, 8.23, 9.56. 3 elements I have given. It is storing. Okay, again elements in heap are some mistake I have done. Here percentile d I have used. While storing percentile d I have used. It should be percentile f. Okay, so this is how you can check. Yeah, now it will give the output because again I need to do the entry. Okay, nevertheless I will do first value, second value, third value, fourth value, fifth value. So we are getting 5 values, now 3 values, modified 3 values, 4.5, 6.3, 2.3. You can see 4.5, 3. Yeah, here while printing I have not given the space. This is another mistake. Okay, space I need to give so that you will see the space here between these values. 4.5, after the 6.3, and after the 2.3. Likewise, it will print 4.5 from here to here, 6.3 from here to here, 2.3 from here to here. This is how you will get the output. Hopefully you understood this one. So just go with with this we have concluded your 4th unit, hopefully. Releasing the memory, yesterday's session only we have discussed. To release the memory, we use the free function, dynamic memory allocation function, free function. To release the memory we use whatever memory we are allocating using malloc, kelloc, reallog. If you want to release that memory after the purpose is over, after the job is done, simply use the free function to release that memory. We have discussed ma. So with this we are concluding your fourth unit, dynamic memory allocation functions concept is over, and with this we are concluding your what we call the fourth unit. Okay, so quickly we discuss the fifth unit topics. What we have in fifth unit we will discuss. So your fifth unit is about searching and sorting ma. So okay, searching means, see, we have a list of items, an array of items, array of elements are given to you. Say suppose 100 items you have in that element, in that array, and I'm asking about a particular item to be checked in that array, whether it is there or not. So say suppose you have some randomly entered elements, randomly entered values into the array. So like this, I will show here. Okay. To understand the concept of searching and sorting, what do you mean by searching and what do you mean by sorting? Okay, these two things we need to understand: searching, sorting. Okay, searching means basically these two operations, whether searching operation or sorting operation, we perform on an array of elements. అరే ఆఫ్ ఎలిమెంట్స్ పైనే పర్ఫామ్ చేస్తామమ్మా. ఇక్కడ మీరు క్లియర్ గా చూడొచ్చు, బేసిక్ సర్చింగ్ ఇన్ అన్ అరే ఆఫ్ ఎలిమెంట్స్, బేసిక్ సార్ట్ array of elements. Okay, basic algorithms to sort array of elements. Both operations we are performing on array of elements only. Okay, searching means what? Given a list of items. Okay, ila icharu meeku list of items icharu, maybe say some n number of elements you have in this list, that n we don't know how many. Okay, n number of items they have given, and all these items, they are filled with values. Okay, we have values like 3, 4, 7, 1, some randomized 22, 24, like this we have all the values. Okay, what values we have, we don't know. Okay, so I'm asking you to look for a particular value, say 23, whether it is existing in the list or not. 23 value గురించి చెక్ చేయమని చెప్తున్నాను, whether it is there or not. So what you will do ma, element by element you do the comparison. ఈ 23 ని ఏం చేస్తారు, element by element చెక్ చేసుకుంటూ వెళ్తారు, unless you find that 23 in the list. If it is found, what you will say, yes, the element is existing in the list. If it is not found in the list, what you will say, no, the element is not existing in the list. That is what the searching operation. But of course, as we need to perform through code, as we need to write the program, how to perform it, and what are the complexities we will get when we perform this searching operation, that we will discuss in this topic, searching topic. And on the other hand, we have the sorting algorithms, sorting techniques. They will simply arrange the elements either in ascending order or descending order. We know ma. Okay, ascending means what? Small to big. We know na, small to smallest to biggest, small to big, and descending in the sense big to small. In this order, they will arrange your sorting algorithms, arranging the elements in a list of elements, arranging the elements either in smallest to biggest or biggest to smallest, either in ascending order, or in descending order. That is what we call the sorting approach. Okay, okay, it is very simple ma, sorting approach. Okay, so searching means searching for a particular item in a list of items, in a list of elements, in an array of elements. If the element is found, we call it as a success case, and if the element is not found, we call it as a failure case. Same thing. Sorting means arranging the elements, arranging the sorry array of elements either in ascending order or in descending order. Okay, descending order. Ascending means smallest to biggest, and descending means biggest to smallest. So for searching, we have two algorithms, two types of algorithms. One is linear search. The first one is linear search, linear search algorithm, and the second one is binary search algorithm. Binary search, linear search and binary search. And for sorting, we have many algorithms, like we have bubble sort algorithm. Second one, we have insertion sort. We also have, say, selection sort. Okay, then we have fourth one, merge sort. We have quick sort. We have heap sort. Likewise, the different sorting algorithms we have. Our concern will be the starting three. As you can see in your syllabus, they're asking us to discuss only bubble, insertion, and selection sort algorithms. Only three. The first three we will discuss: bubble sort, insertion sort, and selection sort. Others we will not discuss. Merge sort, quick sort, heap sort we will not discuss. Only the first three we will discuss. And searching algorithms, what they are asking us to do: linear and binary. Both searching techniques we need to discuss. This is one, this is two. And sorting techniques, this is one, this is two, and this is three. Okay. In tomorrow's session, I'll be discussing about the basic searching algorithms on an array of elements, that is linear sequential search. Linear search is also known as sequential search. Sequential search అని కూడా అంటారమ్మా. లీనియర్ సెర్చ్ నే sequential search అని కూడా అంటారు. So linear sequential search and binary search we are going to discuss in tomorrow's session. And after that, one more class will be for discussing the sorting algorithms: bubble sort, insertion sort, selection sort. All three I will try to complete in a single stretch, in a single online session. Okay. After that, we will be discussing about the basic concepts of order of complexity. So order of complexity or complexity of the algorithm, it can be measured in two notations. One is the time complexity of the algorithm. Okay, it is very simple to understand. When you execute an algorithm, down we are getting the compilation time, execution time, likewise. So that is what time complexity is nothing but the amount of time an algorithm is taking for execution. That is what we call time complexity of the algorithm. And there is another notation, that is another parameter which we need to consider whenever we are going for order of complexity, that is space complexity. We need to discuss about space complexity. So space complexity is nothing but how much space your algorithm is consuming when you are performing the when you are writing it. Okay, when you are performing the steps. Okay, time complexity is nothing but amount of time the algorithm is consuming when you are performing the steps, and the space complexity is nothing but the amount of space the algorithm is consuming when you are performing the steps. Okay, this is what time complexity and space complexity. To measure, we have certain notations, we call it as asymptotic notations. The term, I know if you have not heard it, if you are hearing for the first time, it may look somewhat strange or somewhat new to you. So the term is, we call it as asymptotic notations. Asymptotic notations. to measure the time complexity and the space complexity, we have to go for A. This is A, capital A, asymptotic notations. We have three different notations, ma. The best, worst, and average case notations. The big O notation, we call it as big O. Big O. It is something like MNO, alphabet O. Big O notation. And the second one is theta notation. Okay, theta notation. And the last one, omega notation, like this. Okay, omega notation. And to explain these basic concepts of order of complexity, maybe another class, one more class. So here for basic searching techniques, one class. This thing may be 1 hour, 1.5, and this thing 1.5. Like this you can take. So total overall 4 classes I'm giving for this fifth, 4 online classes, not offline. 4 online classes I'm giving for this fifth unit to complete. Hopefully you understood. So with this understanding on fifth unit, what we are going to do in fifth unit, searching algorithms, sorting algorithms, and the complexity, order of complexity, how to do it. I'm concluding today's session, and more in detail about this fifth unit in tomorrow's session we'll be discussing. Thank you very much.